Hey guys, Mr. Brading here for the first installment of the acceleration lecture. In this one, I'm going to be covering mostly the actual visual representation of acceleration. So be able to determine if acceleration is occurring when given a scenario or visual representation. There's a couple ways to visually represent acceleration. There's the graph, where you have either a distance time graph, velocity time graph, or actually an acceleration time graph. You can use any one of those three graphs to visually represent um, acceleration and figure out if it's happening or not. I have another video up that in this same section that shows you actually how to go from one graph to another, and being able to do that is going to help you understand the visual representation using graphs very well. The other way to visually represent acceleration is using strobes or the ticker tape timer. Okay, um, I'm not going to talk about these other ones because otherwise, if I were to also talk about calculating acceleration in this first installment, it'd get way too long. So let's go ahead and get started here. So here, I'm going to go ahead and start here because it should just show some simple cars. So again, if we think back to the old strobe photos that I showed you guys, where it just had cars that it was here, here, and then it just was a consistent distance from one car to the next. It was showing that there is a constant velocity. If the distance between the cars stays the same, that means there is a constant velocity. And if there's a constant velocity, we know there's no acceleration at all. All right. Now, we look at these cars and it goes from a short distance to a longer distance to a longer distance. So you can figure, where is this thing going the fastest at? It's going the fastest at wherever the distance is the largest, okay? Because all these pictures, let's say this was taken at 1 second, 2 seconds, 3 seconds, and 4 seconds. There's only 1 second in between each, and so the fastest part is right here where the distance is the largest. All right. So by looking at this visual representation of a strobe photo, we can see that this car is in fact accelerating positively. It's going faster and faster and faster. Now, a ticker tape timer does very, very similar thing to the strobe photo. What it does is it knocks down on a piece of paper and leaves a little black dot about 60 times every second. So it's really, really fast. And so if we pull tape through a ticker tape timer really slow, those dots are going to be really close to each other. If we pull it through at a medium speed, the dots are further apart and then even further apart. Now, if it's actually accelerating, what's going to happen is you get the dots close together and then further and further apart. Now, if you have negative acceleration rather than positive acceleration, just like this shows here, those dots get closer and closer and closer together. Negative acceleration is another way of saying decelerating or slowing down. Okay, and another way of saying positive acceleration is speeding up. Okay. So again, this is actually a really, really simple concept, and all they did was here they just put it on a graph of what it actually looks like. So here, this is a velocity time graph. They did 3 velocity time graphs and then 2 velocity time graphs. You can see the velocity decreases, velocity increases, velocity remains the same, velocity remains the same, and velocity remains the same. You have a flat line. All right. Nice short lecture. In the next installment, I'll be talking about how to actually calculate for acceleration. If you guys have any questions, make sure you write them down. Other than that, see you guys next time.